We will be solving equations with variables on both sides. When we have an equation like 20 minus 3x equals 2x plus 5, there are variables on both sides. So when you get ready to isolate your variable, you can't. You don't know which one to isolate. So when they're on the same side, what you do is you combine them. But when they're on opposite sides, as they are in this case, what you've got to do is you've got to get rid of one of them. Now my rule of thumb is which one to get rid of is to get rid of the littler one. Because if you get rid of the littler one, usually that will eliminate a little bit of extra work. You don't have to. You can get rid of either one you want. But that's what I do. I go through and I look to see which one's smaller. So let's look. I have a negative 3x and I have a 2x. That's my variables. So I think to myself, well, which one's littler? Is negative 3 smaller or bigger than a positive 2? Of course it's smaller. So what I want to do is I want to get rid of that negative 3x. Not just the negative 3. I'm not trying to isolate that variable yet. I want to get rid of that whole entire term. So I want to get rid of the negative 3x. To get rid of that minus 3x, the way that's written, I have to do the opposite, which is actually add 3x. So if you have a negative 3x and you add 3x's to that, that makes 0 x's. That's what makes that cancel out. If you do that to one side, you're going to have to come over here and do it to the other side. So when I add 3x's to 2x's, that gives me 5x's. Now what I do is I haven't used these other numbers, so you just bring these other numbers down. And what's left is a two-step equation. Isolate your variable. First, you want to get rid of that plus 5 when you're solving by subtracting 5. 20 minus 5 is 15. Bring down the 5x. Now here's where we wanted to separate the 5 and the x. So at this place, we'd have to figure out that's 5 times x. And to separate the 5 out, we'd have to divide it out. If I divide it on one side, I have to divide it on the other side. That leaves x, and then 15 divided by 5 is 3. Now, if you have 3 equals to x, a lot of the times you just want to go ahead and swap it and write x equals to 3. It doesn't really matter. It's just more standard to see the variable written on the left side than on the right side. So either way is correct, but on a test like the ACT Aspire, you're going to have x equals to 3, probably not 3 equals to x. Alright, let's try another question. Let's say I have 4x plus 1 equals to 3x minus 9. Okay, I separate my two sides. And I do see I have a variable on each side. So what I want to do is I want to get rid of one. Again, I like to get rid of the smaller one. 3x's, that's smaller amount of x's than 4x's. So to get rid of it, since it's a positive 3x, I'm going to subtract 3x's out. Because if you have 3x's and you take away 3x's, that leaves nothing. That's what you want. But if you do it on one side, you're going to have to come over here and you're going to do it on the other side. If you have 4x's and you take away 3x's, that just leaves 1x. We don't write the 1 in the front. Okay, now everything we didn't use, we just bring down like this plus 1 and equals negative 9. This is a one-step equation. The only thing that we have to do is get rid of that plus 1 and then the x will be isolated. So if you want to get rid of plus 1, you just subtract 1. Negative 9 minus 1 gives me negative 10, and there's my solution. X equals to negative 10. Let's just do a couple more examples, some that are a little bit different. If I have 5x equals to a negative 7x plus 6, this one looks a little different, but we don't do it any differently. I still have variables on each side. I still want to get rid of one of them. I choose the smaller one to get rid of. How do I get rid of the minus 7x? I plus the 7x on both sides. These cancel. 5x's, add 7x's to it, gives me 12x's. Then what I'll do is I'll bring down this 6 since I didn't use it. Here's where I would divide out my 12 to get rid of that 12 since it's 12 times x. And don't get confused by this right here. That is 6 divided by 12, not the other way around. 6 divided by 12 is 1/2. So x equals to 1/2. That one actually was a little bit easier. It was just missing a number. It looked a little bit different. I wanted to make sure that we saw one like that. Let's do one more. Because, you know, I've been saying here that we usually get rid of the smaller x. Well, that's not always necessarily so. You don't have to. And in this case right here, in this problem, 17x minus 6 equals to 14x, I don't want to do that. If you'll notice, the 14x is the smaller x, but if I get rid of it, it doesn't leave anything left on that other side, which actually makes it a little bit more confusing. So in this instance, this type of example, I actually want to get rid of the larger x. Like I said, it doesn't matter which one goes first. It's just easier usually to do the smaller one. So I'm going to subtract out 17x from both sides. That'll cancel. That'll leave a negative 3x. 14 minus 17 is negative 3. Bring down my negative 6. When I isolate my x here, I'm going to divide by negative 3. That's negative 3 times x, so we divide to get rid of it. Negative 6 divided by negative 3 is a positive 2, and I always like to rewrite to get my variable on the left. So x is going to equal to 2. So remember, when we're solving an equation that has a variable on both sides, it is sometimes easier to get rid of the smaller one first, but it's not necessary.